Hi, my name is Keith Ransom, and this is a pre-recorded presentation for the 2021 meeting of the Australasian Mathematical Psychology Conference. The work I'm talking about today is joint with Andy Papors and Rachel Stevens. Okay, so reasoning is hard. We're frequently faced with situations where we have to make complicated inferences based on very little data. Yet inductive reasoning based on sparse data is something we're good at, even though it can sometimes backfire. In these relatively simple situations, people are known to exploit properties of the sample itself. For example, the number and diversity of the items observed. And people are also known to exploit their assumptions about how the data were generated in the first place. But many everyday reasoning problems are more complex than in the examples that I've shown so far. For example, consider reasoning about the claim, perfect avocados are getting harder to find. And imagine that you've just seen this claim made in some social media posts. This is certainly the kind of punchy social commentary that I like to follow on Twitter. That says more about me, perhaps. How would you evaluate this claim based on the sample of the data that you've just seen? Would you rely more on the data itself or on your thoughts about how the data was generated? Regarding the data itself, compared to the previous examples, the structure of the conceptual space in which this problem might be represented, it seems more complicated. So it might be higher dimensional, it feels like it's probably populated with less prior data, and the representations may be more ad hoc in nature. Regarding the process by which the arguments were generated, intuitively reasonable assumptions extend well beyond helpful or random sampling. Whatever the case, there may be significant uncertainty regarding which assumption applies. For example, people making arguments in support of a claim in an environment like Twitter, well, they have unknown knowledge and intent. So looking at the tweets shown here, is the author of these tweets more likely to be a culinary enthusiast or a lobbyist for big avocado? Our sampling assumptions may be further complicated based on what we think about the independence of individual arguments in the sample. If the same person offers multiple arguments, for example, were they acquired and verified independently and then used to support the conclusion, or were they derived post hoc from the conclusion? Similarly, if multiple people offer the same argument, did they independently conclude that it was best, or did they all watch the same documentary on Netflix? So to begin to get at some of these issues about how people reason from information and assumptions in rich social contexts like social media, we decided to run an experiment. So while our longer term goal is to build on existing models of induction, social sampling, and evidence aggregation to kind of define a normative standard for how people should reason in this kind of situation, our goal for the experiment was to obtain some empirical evidence for what people actually do. And we wanted to do so in a realistic social context and using a wide variety of stimuli. So we ran our experiment on Mechanical Turk. And for it, we used a Twitter-style interface like the one shown here. So on each trial, people were shown a neutrally worded post and were asked to rate their agreement with a given proposition statement. After giving their initial rating, people were shown a series of tweets in reply to the original post. And then they were asked to read these tweets and update their agreement rating. So the set of tweets that people saw on each trial varied according to our experimental design, which manipulated three key factors. And I'll step through the design now into more detail. So in general, each trial contained a set of target tweets and a possibly empty set of opposing tweets. There were always 4 target tweets, and they were either all in favour or all against the proposition or the claim that we'd given them. In this example, each tweet has a different author, and each person has made a different argument. So the number of opposing tweets was varied, and that was a between subjects manipulation. So if the targets were in favour of the proposition, the opposing tweets were against it. And and vice versa. So whether the target tweets appeared to come from the same person or different people was varied within subjects. And similarly, whether the target tweets made essentially the same arguments or different argument also varied within subjects. So this 2x2 design represents the majority consensus condition, where the target tweets outnumbered the opposing tweets 4-1. So there was also a full consensus condition and a contested consensus condition. So making 12 conditions in all. Now let's see some results. So recall that for each trial, people gave one agreement rating before reading the reply tweets and one afterwards. Okay, so firstly, here are people's prior ratings aggregated across individuals and all conditions, but broken down by topic. So note that the actual proposition statements that we use are abbreviated in some cases here. So we chose the topics and the associated propositions with the aim of eliciting a wide range of prior distributions. And indeed, I think the plot shows that the propositions are varied both in terms of their overall support and in terms of the distribution of beliefs. And now to show you the ratings that people made after seeing the reply tweets. So here we see the results from the full consensus conditions. And I've plotted people's ratings separately according to whether the target tweets represented arguments in favour of the given proposition, so shaded in green, or whether they were against the proposition, shaded in blue. So the separation between the two distributions is kind of a measure of the weight of evidence contained in the positive and the negative arguments. So the greater the separation, the greater the evidence. So this plot gives us a way of visualizing whether a 2x2 manipulation had any effect. And so you can see that when the target tweets appeared to be written by different people, they seem to carry more weight. Looking at the majority consensus condition, we see less separation in general, which is to be expected because there's now a single counter-argument being made. But nonetheless, we see essentially the same pattern repeated. Arguments from 4 people appear to carry more weight than if the same arguments came from a single individual. And so finally, in the contested consensus condition, there is no numerical advantage for either side of an argument in terms of the number of tweets. And yet there is still a hint of an effect of the number of people presenting the target tweets. If we zoom in on the 4 panels, we can see that for the 2 panels on the left, the relative positions of the green and blue lines is reversed. So implying once again that when the target tweets come from the same person, they carry less weight. To give you a more concise summary of the overall effects, I'll show a plot of what I call the spread of belief across all 12 conditions. In this plot, you can clearly see what influenced people most. So in the 3 consensus conditions, we varied the number of opposing tweets, and this had the greatest impact. There's also a clear effect of source diversity, that is, whether the target tweets were from one person or from 4 different people. And in contrast, whether the target tweets represented 4 distinctly different arguments or 4 versions of the same argument, this appeared to have little effect. Okay, so to better quantify these effects, we compared how 4 different linear regression models captured our data. So each model predicts people's posterior agreement ratings on the basis of their prior ratings and 0 or more measures of consensus. And we found that the 4th model gave the best account of the data after taking model complexity into account. And so to give you a feel for effect size, I've plotted some simulated agreement ratings under various conditions. And if you like, you can pause the video and read the text if you want the details, because they're quite long. But this example illustrates that an imbalance in the terms of the number of tweets on each side of an argument has the greatest impact on belief revision. So it's roughly twice the impact that an imbalance in the number of distinct people has. And somewhat surprisingly, sharing distinct rather than repeated arguments has a small negative impact. Okay, well, now for some final thoughts. So people appear to depart from statistical principles when reasoning from data samples. Indeed, prominent models of inductive inference have enjoyed success despite the lack of any explicit mechanisms for capturing people's sampling assumptions. And yet, there's mounting evidence to suggest that people's sampling assumptions are important in shaping even simple generalizations. And importantly, they may matter even more in situations where the psychological space that we reason in is more complex, more uncertain, and most of the data that we have to rely on is socially generated. So using a variety of topics for which people had a range of prior beliefs, we demonstrated that people's assumptions did play an important role in shaping their beliefs. So I think our experiment represents a step towards a more methodical examination of how people reason in such situations. So having only just run our first experiment, much of the work remains ahead of us. Our starting point, though, was that a priori claims about the relative quality of a consensus are problematic. When is a consensus a true consensus and when is it not? It seems unsurprising that people find it hard to reason about this kind of thing in situations where things like ground truth, source independence, reliability and intent of individuals, all of these things remain latent. So we want to think more about what a normative stance should actually be. We also want to follow up on the issue of argument diversity to better understand when it does matter and when it doesn't. So work in the literature on explanations, for example, will be a likely starting point here. And well, I'll leave it there for now. Any questions? My email address is shown at the bottom of the screen. Otherwise, thank you for listening.